Okay. Our final factoring topic is factoring four-term polynomials. So let's, in way of review, let's go through our entire checklist here. When we are factoring, I want you to kind of always get used to going through this checklist of things. And we may make an anchor chart or something here that we can kind of look at to reference this. But if we're factoring up binomials, and some of the examples that we just looked at required us to do these three things in that order. You have to do them in that order. If you do them out of order, then you end up with something that can still be factored, but you don't have the skill to factor it. So it's important to do GCF, difference of squares, and then cubes, right? And if we're factoring trinomials, the first thing we're going to look for is a GCF. And then we're going to do some type of trial and error factoring. There's different methods that people are using. You can use circle, slide, divide. Unfoiling it is the method that I prefer to use for that. But y'all talked me into doing something different this year. Four-term polynomials is what we're looking at today. We're going to do look for a GCF, which we've already done. That's easy. You can do that. The next thing is grouping. Grouping is also really easy. Most people find this method of factoring pretty simple. Compound squares, not so much. Compound squares is a little bit complicated. So we're going to look at these factoring methods in that order today. All right, so GCF, grouping, compound squares is the three things that we'll look for when we're factoring four or more terms. And you did this in Algebra 2. So here's our first example. Factor 12AC plus 21AD plus 8BC plus 14BD.
These time intervals versus math.
Do what?
These time intervals.
This is a skill, guys, right? What are we practicing here today? Let's remind ourselves that we're practicing a skill that may be useful in solving higher order or higher degree equations a little bit later. Four-term polynomials do not come into play, factoring four terms, in a practical application, except for when we use grouping to factor trinomials. And that's the part of this lesson that I think a lot of you are going to really like. Because this part of factoring by grouping is pretty easy, right? Do we have any GCF? No. Do we? No. This is A and C. So this first we got a 12, an A and a C. So nothing is divisible by, none of our coefficients are all divisible by the same number. I've got A's here and D's, B's, C's, a D there, but you can't do it. All right. So we're going to jump straight to grouping. Now, if you have four terms, the first method for grouping that we're going to look at is just to pair them up. Let's look at these two terms, the first two terms, and the last two terms. So I'll take those two and these two. And then what I'm looking for is a GCF for each pair of terms. Do the first two terms have a GCF? Yes. What is it? 3A. 3A can come out. All right, is everybody with me? Zach, you with me? Yes, sir. And that'll leave me with 4C plus 7D, right? Okay. Now, do we have a GCF in the second two terms? What is it? 2B or not? 2B. I know that's really bad. But I love it when a 2B comes up in math. You get to teach across the curriculum. It's old Hamlet. 2B. Now, when y'all really get good at this, if you get good at this and start interacting, anytime I say 2B, you should say or not 2B. That's right. Okay. Then we will see what's left if we take out a factor of 2B. It'll be 4C. She just used the same joke over there. And then we'll have 7D, right? Now this is where something neat shows up. What do you notice about these two terms? Both of these two terms, and why do I say two terms? Let's go all the way back to Algebra 1 and pick up a definition here. this initial polynomial expression here has 4 terms. Right? Does everybody clearly see the 4 terms? Yes? First term, second term, third term, fourth term. This expression right here that we have here, this one only has 2 terms. I'm still going through puberty. This one only has 2 terms because in algebra, in math, yeah, we got a little life in here. In algebra, terms are parts of an expression that are separated by plus or minus signs. Okay, so when I've broken this down, now I have a term here. This is one term, and this is a second term. Now, do you notice what those 2 terms have in common? What do they have in common, Will?
I don't know the name of the parentheses are the same.
They have a common parentheses, right? Everything in those parentheses are the same. It works for me. It communicates. So I can take out this 4c plus 7d. I can factor it out, right? 4c plus 7d. And what's left is 3a plus 2b. Or not. No, you messed it. You butchered it. Or to not to be. Okay? Right? So what we do is we treat, because it is, these parentheses are one thing. That's one factor, right? This is one factor. So I can take that common factor out, and when I do, I'm left with 3a plus 2b. And that's factoring by grouping. Okay? That is a completely factored expression. How do I know it's factored? Yeah, because it's 2 things that are being multiplied, right? And factoring by definition means we want to express it as only things that are being multiplied. Okay? Now, if it makes sense, guys, as we go through the process, we started out with 4 terms, right? And then in the next step, we have 2 terms. We want less terms because we want to end up only with factors. And then down here, we have 1 term. There's nothing in this is being separated by plus or minus signs. So this is two factors, 2 things being multiplied, and we're done. So that's not bad, right? Factoring by grouping. Okay, let me click through all this little stuff here that we're going to ignore. And let's do this one. Now this one, Zach has even more. Oh, before we do this, let's go back to this other one. I want to do one other thing real quick. Sometimes you have to regroup things, and when you regroup things, your factorization can look a little different from time to time. I mean, the order could be different. The terms could be in different orders in the parentheses. But if we could take this one and let's rewrite it. Let's say, oh, these have a c in common. Let's put them together. And these have a d in common. They have a factor of 7 in common too, right? So let's put those together. If you regroup, you just have to make sure that you are careful to put your signs the same. Okay? Now,
Do you want to do it in descending order?
no, they wouldn't have to be in descending order. I'm just talking about the signs. Everything here is positive, so that's not a big deal for this one. Now, I'm going to do this quickly because I just want to show you that you have some options on this with this method. We have a common factor of 4c here, so that would be 3a plus 2b. Okay, this one has a 7d as a common factor, and that will leave us with a 3a plus 2b. Right? Yes. So we have different common binomial factor this time. It's 3a plus 2b. And then what's left when I take out this common factor is 4c plus 7d. Now that's the same as last time, right? Just maybe the order's a little bit different. We took out different GCFs. So there's a lot of flexibility with factoring by grouping. Usually, if not always, there's more than one way you can group the terms to make it work. So if you see two terms that really seem to have more in common with each other, it's okay to put those together and then leave the other two, and then just work it from there. All right, so let's look at this second example again. Factor Rx plus 2Ry plus Kx plus 2Ky. All right. Common factor. Is there a common factor across the board? Nothing has. No, just one, and that's not an interesting factor. Everything has a factor of 1, right? So let's group them. Let's take these two and these two, and then take a GCF out of each. What's the GCF in the first pair of terms? R, and when we take out an R, what are we left with? X plus 2y, right? All right, and then we will take what's the common factor in the second one? Second group, what's the common factor? You guys are working ahead. We can take out a k, right? K, x plus 2y. And it happened again, right? Now, if you get to this point and these two things are not the same, then you either did something wrong or it's not factorable by grouping. Okay, because we're just practicing this skill for some other application, I'm not going to give you one that can't be factored by grouping. Okay, so if I give you 4 or more terms, it can factor by grouping or compound squares, which is just another type of grouping. All right, so we can take out the x plus 2y, and what are we left with? R plus k. Okay? Simple enough? Let's do one more and then we'll practice a couple and move on to bigger and better things, more and more complicated things. Now, here's a note, and this is an important one. Recognizing that binomials are opposites is often helpful in factoring. It's also going to be helpful in our next section when we're simplifying rational expressions. For example, 3 minus a and a minus 3 are opposites. Why do we call those opposites of each other? Why are 3 minus a and a minus 3 opposites? Y'all aren't thinking yet today. You just got 2 days this week. You can't take 50% of the week off. Do what? The signs are different. This one has a positive 3. This one has a negative 3. This one has a negative a. This one has a positive a. So if both signs are different, then the binomials are opposites of each other. Right? Now, that means that we can make them look the same. Because 3 minus a and a minus 3 are opposites, they can be made a common factor by taking out a negative 1. You know, because a minus 3 is equal to negative 1 times 3 minus a. Right? Does everybody agree with that? Yes? So you can factor out a negative 1 and change a minus 3 into 3 minus a, or you could factor out a negative 1 and change 3 minus a into a minus 3. And that's going to be helpful to us at some point in time. All right? Now, next example. 2x squared minus 3xz minus 2xy plus 3yz. Now, somebody make some observations. What do you see that's different here? The previous two problems. Do what? We have a square. The signs aren't all the same, right? And the signs, something that I noticed that you may not know how to notice yet, is that the signs aren't in the same pattern. The first two terms are positive, negative, and the next ones are negative, positive. Okay, so this kind of tells me that there may be some opposite factors coming up in this problem. You could regroup it. There's a lot of different things you can do. But let's just dance with who brung us and work through this problem. Do we have a GCF? No GCF, right? Not for all 4 terms. Okay, so let's try grouping these two. What can we take out of the first 2 terms? X. And that'll leave us with 2x minus 3z. What can we take out of the next set of terms? You want to take out a negative y. Why do you want to take out a negative y? To make the ones inside, so you're looking ahead, right? I think that taking out a negative y is the smart move here. Okay, and anytime this sign is negative, let's take out a negative. Fair enough. So let's take out a negative y, and when we take out a negative y, we got to be careful here because we want to multiply it together to get a negative and then a positive. So what's going to be the first term in this parentheses? 2x. And this has to be minus 3z. Right? Does everybody see that? And now we can take out this common binomial factor, 2x minus 3z. And what's left is x minus y. All right, now let's rewind. I want to rewind here a little bit because I want you to see what might happen if you chose to go a different direction here. Let's just suppose you were going to just take out a positive y. Then that would give us negative 2x plus 3z. Now what's the relationship between these 2 factors? They're opposites, right? How do you fix opposites? Factor out a negative 1, so that would be negative 1y, and that would make this positive 2x and negative 3z. And then you get the same thing that we got before. But as a general rule, if this third term is negative, you need to factor out a negative. And 9 times out of 10, that fixes the opposite problem right out of the blocks. All right, last one. Let's look at one more, and then we'll look at compound squares. This is kind of the winner of this. Try this one on your own. See what you can come up with. Pause. Okay, so what do we get? Y'all see one of your peers for homework. Not a lot, but it'll be a cell phone picture somebody can send to you. All right, do we have a GCF for all 4 terms? Now, look, as I was walking around watching what some of you were doing some good stuff. Some of you regrouped, which is going to work. It's going to be nice. Sometimes you make it a little harder for yourself when you regroup. It's a little easier, I think, a lot of times just to go with what you started with. So what do we take out of the first 2 terms if we just leave it like this? 4k squared, right? And that'll leave us with 4k minus p squared. And because this is negative, we said in the last example we're going to factor out a negative. Right? If that term's negative, take out a negative. Negative what? What's the GCF here? Just 9, right? Because 36 and 9 are both divisible by 9. And that'll leave us with 4k minus p squared. And then we have this common binomial factor. Now if you regroup this, your terms could look a little differently at this point. Don't let that bother you. We can take out that common binomial factor, 4k minus p squared. And that will leave us with 4k squared minus 9. That's being multiplied by that factor. Right? How many of you got there? Good. Anybody go further? Why do we have to go further here, calculus students? Because 4k squared minus 9 is a difference of squares, right? So this is a curveball, and I'm not 100% sure I would give you one like this on a test or quiz, but I just want you to see that you always have to look for that next step. Okay, 4k squared minus 9 would factor as 2k minus 3 times 2k plus 3. And that is the complete factorization of this term, of this expression, not term. Okay? Is everybody good with that? So grouping's not bad, right? Now, what if you have a polynomial that has 4 terms that cannot be factored by grouping? All right. Let's remind ourselves something here. How would you factor x squared minus 25? X plus 5 times x minus 5, because it's the difference of two things that are squared, correct? How would you factor 4x squared minus 9y to the 10th? 2x minus 3y to the 5th times 2x plus 3y to the 5th, right? Just simple difference of squares problems, right? How would you factor smiley face squared minus sunshine squared? Smiley face minus sunshine times smiley face plus sunshine. So whatever the difference is, whatever's going on there, we're always going to factor that as conjugate pairs. All right? So if we have the difference of two things squared, then we're going to factor it as conjugates. Okay? And that's going to come into play with compound squares. Okay? Compound squares, we're going to try grouping. For example, if we tried this 4-term polynomial expression by grouping, we have a GCF here. Go ahead and write this down. I know we're rushing a little bit because we're getting short on time. If we do these by grouping, we have a GCF in the first 2 terms. Do we have a GCF in the second 2 terms? We don't, right? We don't. Right. So we can't factor this by grouping in the traditional sense. If factoring into groups doesn't work, you know, if we put those in groups, we have a GCF, but we don't end up with a common binomial factor, so that doesn't work. If grouping doesn't work, then we're going to try compound squares. Now, compound squares requires you to, instead of grouping them 2 and 2, it requires you to group them 3 and 1. Now, which of these terms is the oddball term? Z, right? Z squared, it's on its own. So we're going to factor this trinomial, and then we're going to leave z squared alone. What's the factorization of x squared minus 2x plus 1? What are the factors of positive 1 that add up to be negative 2? X minus 1 times x minus 1, right? Does everybody agree with that? And we can write x minus 1 times x minus 1 as x minus 1 squared minus z squared. Now what do we have? Smiley face squared minus sunshine squared, right? We have the difference of two things that are being squared. Difference of squares will always factor as conjugate pairs, right? X minus 1 minus z, x minus 1 plus z. And that's how compound squares works.
I always get that up with conjugates like that.
Yes, if it's compound squares, it's going to end up like that. Your trinomial will always factor as something times itself, which kind of makes it nice and easy, right? Okay, now we're going to run out of time if I'm not careful. So here's the application to this. All right, let's go back to what's the problem one of the problems that we worked that was from homework review last night. What was one of those one of the trinomials that you asked me? 3x squared minus 58x minus 40. Bless you. Okay, now let me show you the application of factoring by grouping that's going to be helpful to us. Some of you are going to like this a lot. It still involves 3 times negative 40 is negative 120, right? We just looked at this one a few minutes ago. What were the two factors of negative 120 that we said added up to negative 58? So negative 60x and positive 2x are going to actually replace the 58x. All right, have I done anything? Now I have a 4-term polynomial. I'm going to factor it by grouping. What's the common factor here? 3x times x minus 20. Common factor here, 2 times x minus 20. Right? And what does that leave us with? 3x plus 2 times x minus 20. So we can use grouping to bust up the middle term, the two terms, and then factor by grouping. Okay, what was another one? Let's look at one more like that so you can see it again. 4x squared minus 21x minus 18, right? And we did 4 times negative 18 is negative 72. That's divisible by 3 times negative 24. All right, so in the place of negative 21x, let's write, I don't think it really matters, plus 3x minus 24x minus 18. And we could have done that differently. I think it'll work no matter how you do those two terms in the middle. Do we have a GCF here? What's the GCF in the first two terms? X, right? Times 4x plus 3. And I'm going to take out a negative 6 between these two terms. And that'll leave me with 4x plus 3. Right, so we can factor this trinomial by grouping. We just bust up that middle term and write it as two terms instead of one. That's pretty nifty, right? So then you can multiply 4x times x, that gives you 4x squared. Negative 24 plus 3 is negative 21. 3 times negative 6 is negative 18. Sorry about my phone going off over there. All right, any questions there? All right, for homework, I want you to work the 4 problems on the sheet that we just left behind there. And I want you to work, let me see, I got some here on the end here. Yes, the ones that, what were the numbers? 21 through 24?
21 through 25.
21 through 25, there's 5 of those. And then take a screenshot of these on your way out. These are all compound squares. Yeah, we can do it. Those 5 and these 4.